Hi, and welcome to the last segment in our Algebra 1 review, note-taking guide 2. And in this segment, we're going to solve for a specific variable when given an equation or a formula. And if we remember the idea of balanced scales, meaning what we do to one side of the equation, we do to the other side of the equation, nothing really has changed for us. So in my first example, I have A equals 1/2 BH, which is the area of a triangle, and we need to find height. So that tells me we're going to solve for h. To begin solving the equation for h, we need to multiply both sides by 2. That will eliminate my fraction, and I like to get rid of those fractions as early as I can to make my life as easy as possible. Then next we need to divide by b, and that will leave h standing alone on one side of the equation. Let's take a look and see what this looks like. First, we're going to multiply both sides by 2. So I have 2a equals 2 times 1/2 times b times h. I'm left with 2a on the left. 2 times 1/2 drops out, that's a 1. And I'm left with bh. Now I want to have h standing alone, so I need to eliminate the b. So I'm going to divide both sides by b. And I'm just going to go over this way because I'm kind of out of room on my paper. And the left side remains 2a over b. My b's cancel, and that equals h. So 2a over b equals h. Okay, I'd like you to pause the video at this point and solve for the total resistance. This is a formula that you will use in electrical occupations, which is R sub T, for a circuit in series given the following equation. R sub 2 equals R sub 2 minus R sub 1 minus R sub 3. Pause the video, solve for R sub T, and turn it back on when you're ready to find out and check out your solution. Let's see how you did. Our goal is to isolate R sub T, so to do that I need to add R sub 1 and R sub 3 to both sides. I'm going to move my equation a little bit off this way, so I have R sub 2 equals R sub T minus R sub 1 minus R sub 3. And to isolate R sub T, I need to add the R sub 1 and R sub 3, and I can do that all in the same step, to the right side of the equation. And because I did it to the right, I need to do it to the left, and I'm going to have R sub 1 plus R sub 2 plus R sub 3 equals R sub T, which is the total resistance in a series circuit. I hope you did well. If not, make sure to ask questions in our next class. Looking at example 3, find the radius. So I'm going to solve for R of a cylindrical concrete foundation. So the first question I have for you is, what is the numerical coefficient of my equation? If you remember right, that coefficient is pi. Pi stands for 3.14, etc. It goes on. And the variable r can be solved for in, this is kind of like how many notes does it take you to know a song. This time we can do it in 2 steps. So first, we need to divide both sides by, and I'm going to divide by pi and h in the same step. Then we're going to be left with a square. So to do that, we're going to have to take the square root of both sides. Let's see what this looks like in action. So v equals pi r squared h. My first step, I said to divide both sides by pi h. So to do that, I just divide by pi h, divide by pi h. On the right side, pi divided by pi is 1. H divided by h is 1, so they drop out, leaving me with v over pi h equals r squared. Next, to undo this square, the opposite operation is square root. So I'm going to take the square root of both sides. So I'm going to have square root of the whole side, v over pi h equals the square root of r squared, which is r. Pause the video at this point and give example 4 a try. You're going to find the amount of the taper per inch, in this case a capital T for a tapered shaft, using the formula T equals D minus lowercase d, all divided by L. Oh, and we're going to solve for L, I'm sorry, the length of the metal shaft. So, how did you do? Let's find out. First, we must get L out of the denominator. It's stuck in the denominator. How did you do that? If we multiply both sides of the equation by L, that will get that out of the denominator. So let's go ahead and do that step. T times L equals D minus D over L, and all this is going to be multiplied by L. These L's cancel, so I'm left with TL equals D minus D. And remember, we need to isolate that L, so we need to eliminate the T. To do that, we're going to divide both sides by T. So I just divide by T, divide by T. And remember, you have to do the entire side when you're dividing, just not one of the variables. T divided by T is 1, so I'm left with L equals D minus lowercase d all over T for that taper. I hope you did well. Please pause one more time, and you're going to work with an Ohm's law equation. Restart the video when you're ready. Okay, on the power wheel, there's a formula to find current, or I, and we're going to use the following formula, and we want to solve for R, or resistance. You'll notice I equals the square root of P over R. So what do we have to do first before we can even begin isolating R? In other words, how do we get rid of the square root? In a previous example, we eliminated the square by taking the square root. So to eliminate a square root, we need to square both sides of that equation. In doing so, I'm going to have I squared equals P divided by R. Next, we need to get R out of that denominator, just like in the previous example. So I'm going to multiply both sides of my equation by R. On the right side, R divided by R cancels. So I'm left with R times I squared equals P. And now I still need to isolate R and get it alone. I have one more step. So to get R standing alone, I need to divide both sides by I squared. So I'm going to write over here because I'm out of space again. Ri squared equals P. And I'm going to divide both sides by I squared. Here, I squared divided by I squared cancel, so I'm left with R equals P over I squared as a solution. I hope you did well and continue on. Please complete the guided practice on the rest of your note-taking guide and bring it with you to school. Make sure you show all your work and your answers on your note-taking guide to turn in. If you have any questions, bring them with you to class next time and we'll go over some more examples in class. Have a great evening.